So we've been given the go-ahead, so we would like to welcome you very warmly. Dla tych, którzy nie będą rozumieli po angielsku, we're very sorry, but this is going to be in English because I submitted in English, so if you have a problem with that, blame it on me, it's my fault. Please welcome Ax, that's me, and Wojtek. Today, in the 1201 day of the pandemic, which is technically no longer, but still some countries didn't fully recognize this, so what can we do? And welcome to our talk called Events Uneventfully. So as you can imagine, this is going to be about events. Also, this is the 486th day of Russian invasion in Ukraine, and since yesterday, the first day of the Russian invasion in Russia, which is very, very confusing. So, my name is Andrzej Grzesik. I keep saying that I build stuff, I build distributed systems. Sometimes I keep saying that I hate computers, which is obviously a joke because I still work with them. I have a Twitter, I have an email. If you'd like to talk to me about anything, you're more than welcome to try, and I probably will respond if you email me. Couple facts about me: I'm a Java champion, Java rockstar, or involved in Geekon, Polish Java user groups, a couple of other things, but I will pass the mic to Wojtek.
So I'm Wojtek. I also build stuff, some teams and products. And we decided to do a talk jointly together after probably 10 years of not doing joint talks. So if there are any glitches, let us know. But hopefully you will enjoy it. So I work at Revolut, where I met Andrzej. Actually, he interviewed me. So one of the most shocking things that you can see when you join the interview is Andrzej on the other side. I do CDO morning coffee with a couple of friends that you can join. It's for engineering leaders, I do ride quite a lot of free ride and downhill and free ride in the winter. So that's about me. We wanted to tell you that all opinions are ours. We're not representing anything or anybody, just us. And if you have questions about the talk, let us know. Hopefully see you around, and we can discuss.
And please have those questions. Wave your hands, because there is a person with a microphone available. And if you ask a good question, in any way related to what we're actually speaking about, you can win a mug, an invite to the after party, a bag. So it's probably worth it. And I like using dry jokes in my talks, so let's start. But first, let's talk about what this talk is and what this talk isn't. And basically, the story is very simple. We like to talk about computers. Who would have thought? Over our careers, we've noticed a lot of errors, problems, patterns of errors and stupid things that keep happening. And we started to rant about them, and we did it over a couple of beers, a couple of times, actually more than a couple. And we decided, hey, maybe this should be a talk. And it took some time to materialize, and here we are. So we will not name any companies, so do not think that this is happening at the current place I work or Wojtek works at or anything else.
Yep, and this is we build systems, probably large-scale systems, for many, many years now. So we've seen some really weird shit happening in these systems. So we're going to describe them all to you. What this talk is not. This talk is not about how to do event-driven architecture or even something, even whatever. So that's definitely not. We're going to talk about some mistakes that we've seen and we definitely don't want you to do. Okay.
And I told you I like dry jokes, so let's waste some internet because we will have no cut pictures in here. So,
what is an event? What do we agree on? So if you're here in the room, you probably know that we use events quite a lot in our architectures. So what do we agree on? An event is something that has happened in our systems, right? So there is an action, there is some maybe activity, there is something happening in the system, and it's a confirmation that happened, right? So this is definitely what an event is. We describe them in the past tense, right? To even confirm that something has really happened. And we will talk about that, but events happen in time, right? So you definitely know when these events happen, and you can reconstruct the past. Okay, so what can possibly go wrong? And here is to Andrzej.
And so let's talk about some mistakes. So mistake number 0, because obviously we in most of the languages number things from 0. Mistake number 0 is the basic event, or basic mistake, not making events, not using the notion of events in the system at all. How can you tell that maybe this is something that you've seen, or maybe this is something that you're observing currently? Well, couple of symptoms. This list does not claim to be exhaustive, so there might be more. For example, if you're having batches in your system that are trying to find state changes and try to react to those state changes, this is a good symptom that hints that, hey, maybe you should have actually captured an event and reacted to the event. If you have audit tables, if you're trying to capture all of the changes that a specific entity, maybe a bank account, maybe you're using Enverse, Hibernate something, or some other plugin to something else, maybe there is a space to actually use an event there. I don't know, balance transfer completed, or maybe something more meaningful, customer has moved in, customer has left us. We've sent a bazillion of emails for a marketing campaign, for example. Why? Because what the meaning that we're interested in as engineers building the system, and the meaning that the business person dealing with that system is also interested in, is that an action took place. Figuring out that an action was maybe initialized, maybe completed, maybe it failed at some point is important, similarly to the fact that the state of the action is whatever. So capture this. And another very interesting pattern that I keep seeing very often is business methods that start having more and more and more and more and more responsibility. So generate bill and send updates to customers and maybe send email notifications and maybe something and something and something. As in, yes, it's great if those things are having a single entry point, but is it really a single one unit of action? Should it be considered atomic, or maybe those are actually chronologically involved and one action should follow the other? But maybe the trigger is maybe a bill has been generated, and this is actually where divergence into different activities happens, and this is how it should happen. So if any of those look familiar, and if your reaction is nobody ever makes those mistakes, I sadly have to say those problems are still very much alive in so many systems out there. What is the solution to these basic mistakes? Obviously, start having events. Introduce the concept of an event to the system. So capture a business change, capture the discrete transformation of reality into an entity, just like you have an entity of maybe a user, maybe a customer, maybe their bank balance. And OK, so I've captured it. So I have this data object. What should I do with it? Put it in the data store. The same place as you store your entities. It can be the database, and everybody's going to be OK with that. You don't have to invest in the most heavy outgunning artillery out there, like Kafka, for example. Nothing wrong with Kafka, don't get me wrong. It's just you don't have to get Kafka in order to work with events. You can put it in your DB, and you will be fine. Another aspect is audit tables instead of events. If you're doing audit tables, that might be OK. But if you're doing processors that try to go through those audit tables and try to infer what actually happened, and then maybe look for changes, or maybe something even worse, they might take regular snapshots of tables and then try to decide, hey, this has changed versus that one. Why do it? In many cases, the interesting factor, the fact that's interesting and relevant is a change event happening to an entity within the original table, which means why search for it if you can actually store it and do that? And again, it sounds like common sense, but I've seen it way too many times not to mention it out loud. Yes, audit tables are OK, but capturing events, if that's what's important, is awesome. Another aspect is not capturing the important events. So there is a concept probably originating from domain-driven design, or this is where I heard it from, of something called pivotal events. Pivotal events, something very important happening in your system, like order added. So customer has made an order. This is a state from which recovery becomes much more complicated. If you're assembling a card on an e-commerce website, adding an item, removing an item, rollback out of this is trivial. But once you pay and the order starts being processed, rolling it back is more complicated. So order checkout completed is a very good example of a pivotal event. If you have such important events in your system, store them in the DB. Why? Because they will tell you a story. They will tell you a story of what's happening in your system in business terms and in non-recoverable terms. And so I've said about not doing events. It would be unfair if I didn't say about something quite the contrary. Using too many events. How do you know if what you're capturing is enough, just right, or maybe actually you're on the extreme? If everything becomes an event, and everything becomes an event that you store, and maybe those events make sub-events or the heavy events together, and this is always captured everywhere, this is probably going a bit extreme. Why? Because some events are not going to be as important as material. Some might be purely technical. Some might be just purely internal. And maybe some will not be worth storing, which means you can just drop them or store them for a few days and then forget about them because nobody cares. Item added to a cart, item removed from a cart. You care about it when you're working with a cart, but once a cart has been processed, you will probably not care about it too much.
And I will come back to that, yeah.
And so, yeah, we have events. How do I identify them? Obviously, the content of the event is very important, but you also will try to give them some IDs. Obviously, this will happen, and identifiers will be a problem to some people sometimes. Why? Because you can use UIDs, which are quite useful, and I'll talk about it very soon, but there are also places which, for example, have mixed ints or longs or anything similar with UUIDs, with nano IDs. And this is a problem. This is going to lead to a problem. Why? Because starting with int, you probably know this already, it's a poor choice because it has a very limited amount of values available. Typically, int, or an int in Java, in the positive space, 2 billion values. That's not a lot if your system is going to stay working for a long time. If you think that this is not going to happen, well, there is a thing, for example, with Postgres in which transaction identifiers can actually wrap. And then, unless you reset it, you might end up with a problem. So don't do ints. Longs are better, but there is a problem with longs and ints. You can enumerate them. If you, for some reason, have an API that exposes those events by ID, and I start querying event number 1, event number 2, event number 3, I can figure out how much events there is in the system, which seems not to be a problem. But if you can discover that a company has had 100 events after 1 week and 200 events after 2 weeks, you can establish how much business it was processing, which means if you're an investor or maybe an insider trader or something else, you can use this information. The solution to that is trivial. Use something random. Usually, UUID is the answer. Why UUID? Because it is random. Plus, it has a structure, so you can verify that something is a UUID. It's a known set of characters. It's easy to verify that a UUID fits or doesn't fit. And then come front-end people. In some domains, UUID is a bit long, because it is long. And there is a thing, or there are many things. One of the example of which is nano ID, which is basically some random characters, which can be mixed with UIDs. The moment you start mixing, you lose being able to verify. You lose being able to tell your events apart, and that's very, very tricky. On the front-end side, I have no problem with nano IDs if that's part of your business domain. But under the hood, under the belly, maybe stick to one scheme. And then some side notes. For example, nano ID has 126 bits. So if you've never seen one, now you know, versus 122 bits of randomness in UUID v4. What is this v4? We'll talk about soon, very later. Nano ID has a wider alphabet, which means you can get more characters in there, as opposed to UID. And it has no dedicated storage type, which seems to be an important thing if you store them in a database, because that becomes text. And databases can understand UIDs, like, for example, Postgres can understand a UID. So it has a type. and it has the conversions associated. JavaScript people sometimes quote smaller and faster with regards to nano ID, but I am very cautious about taking performance recommendations from people who have gone through the left path drama and some other similar dramas as well. So, UUIDs. This is what it looks like. Hello, audience, UUID. UUID, audience, now you know each other. If you're a Windows user, you might call it GUID for some other reason. I don't know why. I'm not interested. UUIDs has variants and versions. In short, that's the summary. They can store the time and a MAC address, or they can offer some level of security. They can also be name-based. So a string can be an input to the UUID, which obviously reduces the randomness, or they can go version 4, which is pure random. If I take a random generator of UUID in the command line, I get those options. So you run it twice, you get different strings as expected. One note, timestamp, as you have here. You can store timestamps in a UUID, which is a useful hack. It is useful because if you benefit from it, obviously this has value. But time is measured in 100 nanosecond increments since 15th of October, 1582. You don't have to remember that date. This is a very arbitrary point in time in which they started. It just so happens. And remember, 100 nano increments, which means if your domain is operating at second resolution, you're happy. If you're high-frequency trader, not really. But when is it useful? If, for example, you store transaction date in UUID, because then you can use it to optimize lookup. UUID versions. This is how you put it using the string, which I mentioned. You can see some of them repeat. And then let's have a look at another UUID, specifically this bit. You can see the thing in the red frame, which says B42 da 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 da. Because the room is big and there is a lot of characters there, that's what we're interested in. So a UUID can indicate a MAC address. Obviously, in current day and age, the question becomes which MAC address. And if your system has Docker, wireless, wired, if you still do, or you have a USB built wired, then, well, good luck. So relying on the MAC thing it is possible, but I would not recommend it. And I mentioned the time that you can store in a UUID, and you can do it, but there is one catch. If you decide to, you will see that now, which is an instant, will give you 6 digits of precision after the dot at the very end of the millisecond precision. UUID-based timestamp is going to give you up to 3, which means it's a problem. The code that does it is very simple, and you can look it up on Wikipedia, or you can ask ChatGPT to generate it for you again. This is quite powerful if you want to, for example, optimize time-based partition search or shard replica hierarchy in some reason. And also, I am talking about UUIDs because they are unique enough to serve as correlation IDs, which means it's a good and useful thing to, for example, have a pivotal event as a UUID key and carry it as your correlation ID. So should you use UUIDs in your events as an identifier? Yes. But, of course, there is something even better. The something even better is composite keys, which means think not only about the identifier, because if you look at an UUID, it's hard to tell which domain it belongs to, but put, for example, payment ID hyphen UUID, and then you have the best of both worlds, because you can parse it, and you can derive meaning, and you know what kind of event you're looking at. And then we have mistake number 2, which is delivery mechanism, which I already looked at. I know in Wojtek's presentation, Kafka is the villain. And in here, Kafka also seems to be the villain. But again, I have no problem with Kafka or any other specific technology. But if you have a trigger-happy person that wants to use a particular technology because they really want to put it on their CV, and you happen to be dealing with events, there is a good chance that you're going to hear Kafka in the context very, very soon. In most systems, or in systems that are small enough, you probably don't need Kafka specifically. You can keep that in a database. And then you'll hear, obviously, the moaning, MySQL or Postgres is not modern, or only Mongo is modern, like here, if you remember the movie. Or This database is web scale and doesn't do joins, which means it's going to never crash and it's going to be performant and so on and so on. The solution starts to be quite boring, or put boredom in your software. Start with the use case. See what do you actually need from those events. If you just need storage, there is a world in which you can just append events to a flat file. It's a non-exciting world, but it works. You can put them in the same database that you keep your data in, and it works again. Broken and storage can be separate, or if you don't need to solve the problem immediately, you can do that. If you have no clear idea stage what to do, put it in the same database. If you want to hear about some examples about how far Postgres can go, talk to us about events and Postgres at large scale, because it is possible and Postgres can easily deal with this. If you need an out-of-the-box solution in the cloud, there is managed Kafka from Amazon. I've used it. It worked for me. That's all I can say about it. Had no problems. There is Google PubSub, which some people claim that it works quite well. I haven't used it recently, so I will not say anything. And then mistake number 2.1, which means if we store it, then we have to touch immutability. If we talk about events, we said past time. We want to never edit those events. And then reality bites us. A regulator reaches out to the company and they tell us, hey, can you actually adjust it? Or maybe you're dealing with a payment processor which sent you a bunch of duplicated events because they had a bug in their system, and you have to put order in whatever you have. And this is where it really depends on the industry whether you should apply pure immutability, because general rule of immutability with regard to event is a correct approach, absolutely. But sometimes doing it very, very hardcore, so recording things on CDs, for example, will not pass the reality check because things will happen. One example of that is GDPR. Can you put PII in events?
Maybe we should explain. PII, for those who don't know, is personally identifiable information. So have you ever done events that contained an email, IP address, or I don't know, a phone number? So this is the story about, right? So you have immutable system, for instance, Hadoop, if you still work with Hadoop, and you just put all of that data in. And there is, of course, a problem with GDPR.
So the cheap workaround is don't store PII in your events. But the only thing that we can recommend here and take responsibility for it is when it comes to PII and GDPR and legal requirements, talk to your legal teams. There is no technical only solution that will be correct with regards to the law. You have to talk to the lawyers. And so events, storage. There is a consideration point, which means how long do you need to store the events? That's another area in which it is easy to start, and then it can become dangerous, because you might pick a storage that will actually store something for a very limited time, like Kafka with a timeout or TTL. But then it might turn out that because of legal reasons, you need to store data for a long, long time, because you are operating in a domain that actually needs to store data for a couple of years, like 8. So then we get into multiple delivery brokers, which means, which is a very peculiar mistake. Imagine you have 2 applications, and then one application talks to the other. So I talk to Wojtek, and we use text messages, because that works, that's an event. And then I decide that sometimes the network is down, so I'm going to use something else. I'm going to Telegram him. And then soon after that, I'm going to, message him on Telegram, message him on Signal, because why not, on top of that. And this is going to become a problem. If you think people don't do it between applications, sadly, people do. I've seen it this year. I will not tell you where. What is the problem with that? You're going to have a ton of compensating logic that has to account for events coming to you from all different places, and you have no idea why, where from, what order should you apply them in. The solution is, again, quite boring. Don't do it, and factor it out. Serialization, obviously terrible mistake, serializing events using Java serialization. This, for those unaware, will break when you deploy it to production. Why? Because serialization value, unless you make it explicit and it's not here, is going to change, and Java is going to tell you, no, this is not going to work. Somebody could scream here, or maybe somebody actually is thinking in their minds, oh, just use JSON. And obviously, we're in Java world, so we're going to do this. Add JSON creator, we're done. This is actually how a number of companies have been hacked through recent years, because not only magic that framework has to use can come in just bite you, but what can happen is framework can generate the output that it generates, change the output it generates. So it should be stable so that the events that you store now can be read a couple years from now. And if you refactor a field, maybe you change the order of the fields. Doesn't matter. In JSON, it doesn't. But in other format that you might be using, if you automate it that way, doesn't matter. So what should you do? Well, the answers are easy, and you know them already. Test serialization. I'm not joking. Even if you use a framework like JSON, anything else, JAX, write a test that checks that JSON matches what you expect. You will need to change it, and the changes are going to be trivial, but materialize it. And then try to read an old state from JSON to see if it still makes sense and if it still works. This will help you more than you expected. Test symmetry, so see if you can actually inflate or hydrate the event that you've just serialized. Again, I'm only speaking from painful experiences here. And test deserialization of older objects, because the transaction that you have stored in the database in that JSON format, for example, a couple years back, if you need to read it, what then? Does it still work? Can you keep some of those events floating around just to do a sanity check if you can recover and if you can read them, if they are relevant to you? What else should you do about events and versioning? I'm not going to speak more because there is a book about it. There is a link here. It's written by a sometimes regular speaker at some conferences. If you know the backstory, you know. And let's talk about schemas and events. So events, JSON, what fields are in there? Obviously, you would like to have a schema. If you have a lot of if-else logic handling reading of the event within a system, that means that you are probably getting into that. Content of an event is unknown. Trial and error, that will only accumulate over time. This will lead to very nasty, complicated code in which only a single individual in the company will have guaranteed job satisfaction, or maybe lack of satisfaction, but perfect security, because that will be the only person that can touch events. But if you don't have a schema, or people who would like to have a schema always say that, yeah, we wish we had it. And then they will try to bolt it on a couple of years down the line. Maybe they will even finish having it. Events are a communication mechanism, just like your endpoints are. So document them, put them out like documentation. You can automate it. There is a thing called cloud events that you can utilize as a starting point, and that works. So how should you document events? How should you capture schema of events? There is a weak way. It's called code. Why? Why do I call it weak? Because I have not yet seen a company that does 100% of their software in Java and Java alone, which means we will end up with different solutions. Usually, it is around JSON, and also, or maybe not also, but primarily, code is convenient to people that are using this code. The moment you start hiring Python people into a Java shop, they will ask a question, what is this thing? What are those braces? Why do you not use tabs or spaces? Or maybe they will actually start a flame war about it. And then comes mobile, then come web users, then come, I don't know, maybe Go users, maybe Rust will become a thing in your place, or maybe you're still using Scala. Things happen. So pick a solution that's out there. Protobuf is a nice thing. JSON schema is something I've personally used a lot of times. Avro, I used to use it in my Hadoop days. And yeah, start documenting your events as soon as practical. Now, domain and schemas. Include domain name in your schema. Why? Because event names will overlap. Account created in a business context will be a different account created in some other context, and then you will end up with something that's just similar. If your system grows, if your system is that's powering a big multinational corporation, you will have things that overlap. A transaction is a frequent thing. A payment is a frequent thing. If you integrate with a lot of third parties, you will have things that probably translate that third party's events to your own domain. And then they will overlap because they will probably mean the same thing. Event shipped. Event shipped from your point of view, from your own warehouse, and event shipped from somebody else's warehouse. Can it be something different? Can it be something not different? I don't know. So JSON to verbose, and that's obvious. I'm not going to talk about it. Or we can talk about it later. I'm going to jump to this one. Guarantees exactly once delivery does not exist. Sorry, it just doesn't. Lamport has proven it to us in a paper. What should you do or how to approach the problem? The way to approach the problem that I propose is think about what can you tolerate. Can you tolerate missing events, or can you tolerate applying the same event multiple times? Which is called idempotence, as I see from your heads nodding that you know. So if you can accept receiving an event multiple times, idempotence is your friend. If you cannot, and you want guaranteed storage or recording of an event, inbox-outbox patterns are a thing. There is a problem with outbox pattern, which means if I try to look it up, I will get microservices and Kafka, the novelist. Obviously, this is Google just being trying to be too smart. Outbox pattern, in short, is you have a transaction, like customer makes a checkout, and then you store events in the same unit of database transaction as you have your, for example, checkout information. And then there is a thing, an external thing, that's going to read those events that have to be taken out of this event table to the proper delivery broker, and that will publish it. And that's all that is in the outbox pattern. So why do I mention this? Because sometimes it might happen that you might have a fire here. You might have an accumulation of events that's just going to accumulate and accumulate and accumulate. It can thwart the database. It can actually mean that you are so much behind because your event delivery mechanism is behind. What do? You monitor. Or you look at your event weight, and I'll shut up. I'll let Wojtek speak for some.
Yeah, so basically speaking, when you do event-driven architecture, there is always a question, how big should be the event, right? And how much information do you need? And sometimes you probably got to know the limits of the technologies that you're using. How you know that? Everything is getting slower, the network burns hot. I don't know if you worked ever with very high load systems with the network and seen some of the networks really crashing even if you have too many events that are too big. So what can you do about that? First of all, I would ask you to understand what are the events for. What do you need them for? And why do you need to store all of that information? Because it's maybe not relevant. And maybe the approach that you're taking is not the right one if you need to put all of that information in. So definitely think about that. There is a very good presentation that I can definitely recommend about what events are in the systems. So, of course, this is Martin Fowler's, I think, 2018 go-to presentation. So he talks about 3 types of events. First one is notification. So this is only one system notifying another, hey, something happened. What is important about this is a high, very light events, very high decoupling of the systems. But if the one system is depending on the other, of course, there will be a communication needed because we know that something has happened. Now we need to get some extra information. The approach that solves that problem is event-carried state transfer. So these are our fat events. So the problem with fat events is, of course, they're fatty, right? They're enabling to decouple the systems. So there are no additional calls to get additional information, but sometimes they can go very, very big. And some interesting mistakes. I've seen, literally speaking, last week incident was because there was too much put into the event. And the third thing, the third type of the events he talks about is event sourcing. So this is a pattern, of course, to record whatever happened in our systems. I will be talking about this in a moment. So Very interesting mistake. We forget about time, about the mighty time in our events. It is interesting because when we say event in a software development, we know that there is a time, right? But which time? If you see a timestamp field in your event, what do you think it is? It's very interesting because then you have to debug such a system and you need to ask yourself some questions like when it happened, when did we receive it, and when or where have we processed it, right? So that's very interesting problems. If you ever debugged event-driven architecture, you know very well what I'm talking about. So what can we do to solve this problem? LAMP or timestamp. Hands up if you ever seen or heard about this approach. Okay, good stuff. So this is basically speaking for those of you who don't know. You put a little counter in the event, and you increase the counter whenever a system, for instance, a service does something to like processes the event, right? So this is one approach. Second approach that you can definitely do and is very useful is add very explicit parameters when the event was created, when it was received, when it was processed, etc., etc. The problem, of course, is time zones. If the event was created on a mobile device, you can never be sure that actually it was synchronized or what type of time zone it is, right? So whether it's a local or zone. So for your systems, if you're on your own infrastructure or if you're using virtual machines, I would strongly recommend to use NTP as well to make sure that all of your infrastructure is very well synced, and then you can trust at least a part of inside your infrastructure, right? A very interesting problem that I've seen many times in the systems is denying distribution. So you've been on the talk several years ago, you want to do event-driven architecture, and you do microservices, of course, right? And there is a problem. Whatever you do in your system is happening in multiple systems. So something needs to happen in one system, then it has to be processed by the other, picked up by the third, etc., etc. The problem is transactions die because we have, of course, the famous fallacies of distributed computing. So a network may fail, a machine may fail, etc., etc., and they reach impossible states. So this is definitely causing a lot of problems in event-driven architecture, especially around atomicity and consistency, right? So if you never thought about these problems, I definitely recommend following fallacies of distributed computing to understand what can possibly go wrong. And if you go asynchronous way with your microservices, if you go event-driven architecture, make sure that you understand what you can do. And what can you do? Well, first of all, understand what it means now. So very often, when we work with our product owners, they say something needs to happen after something needs to happen, right? So make sure that you understand what is now to your business. Understand what is now to your stakeholders. Very often, now can mean same day, and you can live with eventual consistency. Make yourself comfortable with eventual consistency, and then you make your stakeholders comfortable with eventual consistency. Make sure to use idempotency keys, what Andrzej already described, and get familiar with orchestration and sagas, so distributed transactions patterns. But these are bloody hard. So if you ever done a proper process manager that sits on top of several systems, you know very well that this is very complex. You need to talk to a lot of people, a lot of stakeholders, a lot of service owners, and you need to ask at each step, what happens if it fails? Can it fail? Etc. Can I retry, and so on and so forth. And then, of course, there comes the question that we forget very often about. If it fails, how do I compensate it? Because if you do a transaction in the database, it's being rolled back for you. If you're doing event-driven architecture, the problem is you have to roll it back. And usually there are some patterns to do it. Have you ever traced an event-driven architecture and debugged it? Hands up if you've been in such pain. Exactly. So this is a famous picture, right? Microservices. And this is what we love. We connect them with event-driven architecture. We will be, of course, autonomous, and each team will be able to do their own stuff. Now, what happens if something fails? So, of course, the problem is that you also don't understand what can happen, what are the dependencies between systems, etc., etc. And this will hit you especially hard with event-driven architecture and events. So, what can you do about that? Well, I strongly recommend doing tracing, so-called tracing IDs. You may see them as trace ID, correlation ID. It's an ID that you create when the event is created, and you pass it through the systems. Even if another event is created in this system, you pass correlation ID. So, for instance, if I tap something in the application, that event triggers something else in another system that creates an event, the correlation ID is passed. And you can trace the whole thing through the system. There are tools to do it, by the way. So, the last mistake that I really wanted to mention, and this is probably very important, because after some talks you really want to jump on event-driven architectures, is you end up with very poor quality system. So we worked on an event-driven architecture, microservices. We refactor everything from a monolith. 2 years ago, you completely burn out. It's quite hell, right? Nobody knows what these events are. Nobody knows really where they are, how to trace their, et cetera, et cetera. And the problem is, it's very often that comes is, okay, how do I recreate in such a distributed system with event-driven architecture? For instance, the state. How do I create a read model, right? So something that we show to the user. And I would say there are a couple of solutions. First of all, with your events, make sure that you know what they're doing. So in DDD, there is a concept of ubiquitous language, right? So basically speaking, make them talk to your business, talk to your stakeholders, understand what that event should be. Don't name it yourself. Okay? Yeah, don't name it yourself, and make sure that this is very easy to understand. Sometimes the name can be very long, but make sure that this is significant. Andrzej mentions pivotal events. So this is a concept. Who of you did event storming? Okay, so you know that if you do it, so basically speaking, event storming is the way to plan your system with the business stakeholder, right? And you have several very important key events, and these are the events that business care about. These are definitely the events that you want to record in your systems, and make sure that you identify the right one. Don't be too harsh on yourself. If you, it's not like you have to spend hours. Listen to the people, make sure that you understand which are the most important. The third thing that I would recommend, that Andrzej mentioned, is understand that there are internal and external events. So if you have a system, like for instance, identifying suspicion transactions, if you're working on identifying suspicion transactions, you will care about everything that happens in this process. If I work outside of suspicious transactions, I'm only interested if the transaction is blocked. So you don't need to put all of these events into a global, your global delivery mechanism, whatever you use. You can use your internal one for your internal events, and then pivotal events for your key events, I would say. Another thing that is very useful when you go events is event sourcing. So get familiar with it. Event sourcing is very, very useful. As Andrzej mentioned, you can use a regular database to learn how to use it if you haven't used it. There are some really good articles by Oskar Duduc, by the way, so I definitely recommend them. What is it useful for? First of all, you can audit the system, right? You can audit anything that has happened. You can reconstruct the past, so how the system looked like in the past. And third, if you need to apply changes, because there is I don't know, maybe a regulatory change, right? You're operating in a fintech, and there is a new regulation that comes out, you need to reply them. So you can reply it to events. And use CQRS. So you separate the logic that changed the system, and you can then read the state from the events. There is an anti-pattern, though. A lot of teams that I've seen go CQRS event sourcing all the way. And it's also a very big problem because it's quite a complex, sometimes, pattern. So what I would recommend, make sure that you understand tools that you're using. CRUD is not that bad if you know what you're using it for, right? So CRUD meaning like an API to the database. In Polish, it's entia na twarz I pchasz. You can use CQRS without event sourcing. So this is also very useful. And of course, you can use CQRS with event sourcing if you need auditable system state, you need to reapply changes, and so on and so forth. So this is super, super useful. If you're interested in getting to know about what we're discussing today, we selected some of the books for you. So here is the time to pick up your phones and take some pictures. I will smile for you. So if anyone tells you about learning domain-driven design, they tell you about the blue book. But I will tell you, don't start with it. It's a kind of a book that you read years after years, and every time you learn something new. It's so complex. It's so hard to understand. There is an excellent book by Vlad Kononov, Learning Domain-Driven Design. Super easy. That was missing from the shelves, to be honest, for years. Then I would say go with patterns, principles, and practices of domain-driven design. There is whole bloody good chapters on event-driven systems, on how to do good quality events. And then when you're familiar, when you're comfortable, go with domain-driven design. There is actually a really interesting book on architecture patterns with Python. To be honest, for a lot of people, that could be the best book on the architecture there is there, and it's in Python. So I would say it's very nicely walks you through everything where you start from, through how to build the domain, how to test it, how to actually expose it, and then how to apply event-driven architecture and CQRS. And it's in Python, by the way.
But it's quite readable. I've tried it.
Yeah. So we wanted to thank you. If you want to talk to us, we will be here. And if you believe that you would like to see something else on such architectures and systems with the scale, on event-driven and domain-driven design, we are thinking about actually doing something about this with the community. So talk to us and poke us that, yeah, you should do it. So we will happily do something extra for you. OK, time for questions. There are invitations for the party, by the way, for questions.
How about doing analytics on those events? How would you approach it?
OK, it's a good question. So I think it really depends. What do you need it for? But basically speaking, if you capture a lot of events, you can definitely aggregate them. So it really depends what kind of analytics. Can we add a little bit of context to your question?
I mean, like business. So basically, want to produce some reports for business, but I want to have like separate data people doing that, right? So basically, data engineering and so maybe data scientists, whatever.
So events are really good for auditable history. So if very often, especially for training machine learning models, event-driven architecture can bring a lot of value. If you need to make the business, business reports, what I would use is definitely aggregate them in some form. So for instance, we could use some additional ways of storing aggregated state and expose this to the business.
And with that, thank you very much for your attention, and thanks for coming to this talk.